there. So for today, I'll be talking about our visual programming final project, and there's only two members in here, which is me and Simone. For this final project, we had to select one poem, a different type of poem, and we decided to go for a window. So for this poem, it's about a mother talking about windows are eyes of the house, which is that you can see different type of scenario outside of the window every time. So we decided to make it into season. That's also our project title. So for the concept, four window panels are containing the four seasons, which is perfect, which is spring, summer, autumn, and winter. In the span of a year, the window shows you different seasons of nature. We contain some parts of nature in each season through our artwork. So that is why we decided to pick window just for this concept. Here are the reference for the window. We have sand, we have the mountain and snowy biome, we have the autumn tree, and just like spring flower falling, and like different type of season in one tree. Here are the case study. Without these YouTube tutorial, we couldn't have made it, so they are very helpful. So for me, I have did 2 frame, and our other member has also do 2 frame. So I did the first and second frame, which is spring and summer. For the spring, I decided to make it more like when you look out the window, you'll see flower flowing around everywhere and leaves as well, because that's in the tree. And for this, I decided to use the color that represents spring on the flower, which is pink, purple, yellow, and more. So this is how I make it. The base geometry for the flowers were generated and prepared with UVs and attributes essential for texturing and 3D rendering. Material texture were applied using movie file and tops, specifically for the color, surface detail, and transparency maps to give the flowers a realistic appearance. Individual flower movement paths were defined using a combination of spear SOP for initial placement, noise tops for organic variation, and a trail chop to generate their dynamic flight trajectories. So I use flower image that I find online to input them here, and this is where the color changing is. This is outside of the base. There is 3 base in total, which is I implement 2 flower and 1 leaves. So the leaf, I just decided to change the flower as the flower look kind of like a leaf if you recolor it. And the multiple flower instances were created by feeding the generated movement attributes into a geometry comp for efficient rendering. Randomized attributes like scale were applied to this instance using noise tops to ensure visual diversities. Different flower types of behavior were managed to separate base comps with base tree configured without coloration. The third one, because it's a perfect color for the spring already, so I decided to not change it and just use the original image color. So a 3D rendering environment was set up with a camera and light to capture the flower scene. The window element was integrated using a movie file in top, serving as the frame. The rendered 3D flower scene was then composited with the window for the final output display. So for the second frame, which is summer. So when you think about summer, you mostly think about ocean and the beach, right? Because when it's summer, most people will go to the ocean and have fun and enjoy relaxing water to go swimming because it's hot. So for this, I decided to make it a little bit more special, which I decided to make it into a galaxy sand. So it's more like you feel like you're out of space and you're staring outside your window, you see some galaxy sand that you get to interact with and play with, which is like draw on the sand and make some little image or words. So yes, this one is interactable. The simulation began with a ramp top generating an initial circular height map, then dynamically sized by a constant chop for flexible resolution control. A feedback loop was constructed using feedback top to allow for continuous accumulation and evaluation of the sand state with a keyboard and chop implemented for immediate simulation reset. So when you draw finish and you have nowhere else to draw, you can reset. So you can draw more. Mouse input was integrated using a mouse in chop to capture cursor's coordinate, serving as the primary control for user interaction, as you can see on the left side. A dedicated base count was created to process mouse input into velocity data, which was then filtered for smoother interaction. The processed mouse data was used to drive a transform top within the feedback loop, directly influencing the sand texture movement. Additionally, a constant tops and add top were employed to create a pooling effect, allowing the mouse to actively distort the sand. The sand dynamic behavior was created within this loop using a combination of displace, slope, blur, and noise top operators. So the noise is also how I make my sand into a galaxy looking sand. Without it, it would just look like a normal basic sand. The simulated sand height data was converted into a 3D landscape by instancing box SOPs with their height corresponding to the sand surface. A standard 3D rendering pipeline was configured to properly display the instant sand, including camera and lighting. Finally, a movie file in top served as a visual window with the rendered 3D sand scene composite to appear as if viewed through it. So I zoom in on the sand using the camera and turn the lights around so it's more obvious on the sand, which is like the sparkle for the Galaxy Vive. So these are all the frames that I did for this season. The rest I'll let the other member to explain as they did their part.
Now I'll be talking about the third frame design process, which is the autumn one. I began with an L system. This is to make the tree and to edit its length and size. On top of this L system, I used a sprinkler operator to distribute a multitude of individual points. These points will ultimately become my visual particles. By using sub to top, it allows me to convert these 3D point coordinates into pixel data. From this converted data, I specifically extracted the position of each point. I used some noise and patterns to drive these scale variations, making the effect look much more natural and less uniform. I placed this sphere inside the geometry container, which helped me manage its position and scale in the 3D world. To actually see my sphere, I set up a camera to define my viewpoint and a light to illuminate it, prevent it from just being a dark silhouette. All 3D elements went into a render operator, which effectively takes a picture of my 3D scene, turning it into a 2D image. From this render, I also added depth map to tell me how far the object is from the camera, and an RGB key that helps me select or mask out parts of the image later. I added a Luma blur to gently soften the brightest areas. Afterwards, I pass it through a bloom operator to create a radiating glow around those bright spots. To give this glow a specific aesthetic, I set up a color ramp and use a lookup operator to remap the bloom intensity to those custom colors. I added movie file in to apply the window frame onto the finishing piece, and to combine it all together, I'll apply the over operator. The complete polished image then goes through a knob and finally to the out operator, which is the designated final output for display. Now I'll be talking about the fourth frame design process, which is the winter one. First, I focus on creating the visual for our 3D element. I use noise patterns, layering and refining them. From this, I generated crucial color maps and normal maps. This normal map is key. This makes a flat surface appear incredibly detailed and bumpy without adding complex 3D geometry. I also added a height map for elevation. This stage is all about making the surface look realistic. I took a basic grid and applied a PBR material to it. This PBR material uses all those detailed color, normal, and height maps from the previous step, making the simple grid look very realistic. This detailed grid is then placed in a geo container. After I added camera to change the angle and light to illuminate it, I also added an environment map and fed all of it into the render operator, transforming our 3D scene into a dynamic 2D image. The final step is bringing everything together. I loaded a movie file to apply the window frame on the finishing piece. I then used the over operator to layer the rendered 3D scene on top of it. The completed integrated visual then goes to the output for display. And that's all for our slide. Thank you. Now I'll be showing you our project. For this one, this is the spring one. And each of the base have a different image. The next one is the summer one. Afterwards is the autumn one with the tree. And for the last one is the mountain for winter. And this is the one of it together.